Good morning, good afternoon, or good evening, depending where in the world you're joining us from. Today, we've got a webinar brought to us by SCIO titled The Need for a Universal Measurement Tool in the Grain Industry. And we have Damian Goldring and Bryce Eger here with us. So we'll get to them shortly. But first, if you've been on a GEAPS webinar before, you'll notice a new face, me. Hello, everybody. My name is Carrie Tussler, and I'm the Communications Manager here at GEAPS. And I'd like to welcome you all today and start off with a little bit about GEAPS. All right, everybody. GEAPS, the Grain Elevator and Processing Society, is a global membership association. Looking at that acronym, GEAPS, we've got our GE and the P that represents the grain elevator or bulk handling industry, and then the processing industries. So those professionals in those industries are who make up our membership base. And with that particular group, it just goes to show GEAPS really is that connecting link of what goes on right in the middle between those farmers and consumers. So our mission is to champion, connect, and serve our members and our industry. We have over 3,500 members, including regular, associate, and a growing group of student members. As I mentioned, GEAPS is a global network made up of members representing 46 US states, 6 Canadian territories, and 15 countries. Lastly, GEAPS owns the media company GEAPS Media Group, and that's a collaborative effort that helps just expand our reach in the industry even further. GEAPS Media Group operates brands like Grain Journal, Processing Journal, and a few more, which can all be found at grainjournal.com. And then up there on the screen for GEAPS, the link to join, jeeps.com/join. We'd love to have you all as members. And now let's get to a few slides here about some GEAPS offerings. Starting off, all right, we released 2 brand new member exclusive resources. On the right here, we have the GEAPS glossary. With the glossary, as you expect, glossary of over 600 terms. And we all know this industry has a lot of industry-specific lingo. We got equipment, processes, things like that. So it's a great tool for consistency and really introducing those new folks to all the proper terminology. And then I went backwards. So on the left, welcome to the grain industry course as an available complimentary right out the gate online course for all GEAPS members. This just gives a little taste of GEAPS educational programs, which we'll talk about in a little bit. But this one's great for introducing new employees and just, once again, a great tool for consistency for anyone in the industries. I took the course myself, highly recommend. And I should have mentioned both URLs there on the screen. All right, moving on. So if you like that course, we got 25 more. Online, on demand, take as you wish. Check out the GEAPS course catalog for a topic that suits your interest. You'll earn a certificate of completion with each one. URL there, jeeps.com/online-learning. Anyone can take these, but they're discounted for members, so it's a huge member benefit. Next up, Whole Grain Podcast is, as you guessed it, podcast featuring topics relevant to the grain industry. Our host, Jim Lenz, is a director of global education at GEAPS, and he invites new guests each episode to the show. We've got listeners from 88 countries, so if you're interested in tuning in, they're all on the website, jeeps.com/wholegrain, or find them wherever your favorite podcast app is. They're all there. Just search and be sure to subscribe. I know in our most recent episode, it was our 50th lifetime episode, so quite the powerhouse there. It was on ethanol or E15. That's a great place to start. Just check out most recent there, and then you can filter through and watch whatever else or listen to on the go, whatever interests you. All right, now lastly here, GEAPS webinars. So if you all made it here, you must be familiar with webinars or you've figured it out thus far. Webinars available to all, and then the recordings are posted on our GEAPS video library, which is available only to GEAPS members. So you do have to be logged into your member account to go view this library. Hundreds of videos in there, and you can just filter by topic or event or whatever you want to watch, whether it's a certain webinar, it's all there. Amazing content, great education. The GEAPS Exchange videos are in there too. Definitely a huge benefit being a GEAPS member for this video library. So again, webinars, jeeps.com/webinars, tune in there. And recordings, jeeps.com/video-library. Members only for those. And we just mentioned here GEAPS Exchange. If you're unfamiliar, that's the conference hosted by GEAPS. It is the largest and best show in the grain industry. Save the date next year, February 21st through 24th, 2026. And once again, Kansas City, Missouri. And with that, what you've all been waiting for, I will happily introduce our speakers for the day. Starting up first, we have Damian Goldring. I'll read his bio here. He is an accomplished electronics and electro-optics engineer with a PhD from Tel Aviv University. He brings extensive expertise in areas such as silicon photonics, electro-optical effects, diffractive optics, and photovoltaics. His professional background includes substantial project management experience through leading initiatives in the Israeli Air Force. Damian's technical specialties include nano-optics design, cleanroom processes, and free space optics design, all complemented by a strong leadership in managing complex engineering projects. And then also joining us, we have Bryce Eger wearing his consultant hat today. He's also a former VP of Research and Development at Corteva. A little bit about Bryce. He is a people-centric, results-focused executive. He is passionate about driving growth and aligning operations, marketing, sales, and finance. Thriving on building empowered teams and fostering engaging cultures, Bryce creates workplaces where people flourish. In his 30 years of experience in agriculture, including leading one of Canada's largest mergers, Bryce has instilled a belief in transparent leadership and cultivating potential. His efforts aim to dream big, enjoy the journey, and create exceptional workplaces and business results together. And with that now, thank you again. This webinar is brought to us by SCIO. I'll have Damian pull up his slides for us now, and we can begin the webinar. Looks great, Damian. Thank you.
Perfect. Thank you, Carrie. Thank you very much. First of all, just before I start, I want to thank Bryce for joining us here today. I want to thank all the audience for taking the time and joining this webinar. And I want to thank you, Carrie and Jeeps, for hosting us here. Thank you very much. So without further ado, I'll just get started. So today we're going to talk a little bit about grain quality and the importance of grain quality for the grain industry. So, the grain industry is obviously a large and significant industry for the world. It basically is a big part of feeding all of us humans all around the world. It's the single largest source of calories. It introduces about 50% of the global dietary energy intake. Obviously, a very important industry to maintain and develop. But there's a lot of challenge here because of the growth of the population of the world that's upcoming in the next decades, I would say. And I think it's been that way so far. It's going to be even more in the future. The need to have high yields and high quality products to be able to really feed the world. So I guess if you draw some sort of a picture of the grain industry supply chain from seed companies all the way to processors and exporters, etc. Whatever part of the supply chain you look at, getting high quality is key to having a successful industry, be able to really serve the food and feed industries of the world that will eventually feed us, the human population of the world. This is key, starting from seed companies through farmers, grain innovators, and whoever else is in the global supply chain. I could give some examples to where quality may be very relevant or very useful or important. So for example, if you look at seed companies, grain quality is definitely super critical for the successful operation of seed production and seed development. If you look at research plots where the grain composition must be, provided to the companies to be able to develop new hybrids or new types of seeds. Getting them in high quality and in timely manner is very important. Same thing goes for example, for corn seed production, where moisture testing pre-harvest is a key factor in succeeding in getting high yields and high quality of seeds for corn. At the farm, there could be different use cases or uses for quality information to allow, high yields and high quality production of grain. For example, whoever is growing wheat, protein is a key parameter for handling the wheat, segregating it, learning how to grow it better, etc. And same thing goes for corn, knowing the moisture pre and post harvest at a high accuracy and in real time is important to managing the fields, getting good yield predictions, getting good timing of harvest, and many other decisions and processes are driven by the quality information of the grain. If I look at the grain elevators, getting the quality information of the different grains coming to the grain elevator is something that happens every day. Knowing how to segregate or price or otherwise handle the grain that's being received and then being sent to export or process, etc., is super important. And therefore, having that information in high quality and in a timely manner is very important. I think it's clear and it's also well known that at the end of the day, the quality information of grain throughout the supply chain is something very important. And being able to deliver that type of data to all the parts of the supply chain is very important. I think that when you consider this type of grain quality data overall throughout the supply chain, there's a few key key parameters or key deliveries that need to happen in order to get that data in the way that the supply chain actually needs it. So one thing is compatibility between the different points. Every point in the supply chain will somehow generate that data of quality of the grain that they have, but having a way to be compatible so that the farmer and the seed company and the exporter, they all speak the same language, so to speak. That's something very important. Next thing is the real-time data. So we know that sometimes getting quality data may involve sending the samples to a laboratory or somehow holding the samples, etc. And it can take anywhere between days to sometimes even months until you actually get the results. And being able to deliver data in real time or almost real time is something that can really make a big change or a big difference in many cases versus waiting for the information for a long time. Finally, and I think that goes without saying, but the data must be accurate and trustworthy. I mean, if we're gonna be measuring the quality of grain, it better be accurate. Otherwise, it's almost useless. So these three together, if we're able to form that type of quality data or generate that for the supply chain, we've learned, and I believe that that can bring a lot of value to the whole grain industry. We're at SCIO. This is a big part of our mission is basically making that data, that quality data of grain available for the supply chain. And I'd like to take a few minutes now to present SCIO in a bit more detail. I'll start with a short video and then move forward with describing our solutions and our technology.
Agriculture and food industries worldwide face growing pressure to boost production, improve quality, and reduce food waste. Yet, without in-depth visibility into real-time conditions, they lack the data needed to make optimal decisions. SCIO unlocks the information locked inside materials and foods with a flexible 3-layer solution that makes guesswork a thing of the past. SCIO's sensor layer can be easily deployed throughout the supply chain, powered by near-infrared spectroscopy, It allows for instant analysis of any constituent, be it moisture, protein, fat, or any other metric, illuminating the actionable data locked inside materials. The results are immediately uploaded to the cloud, where SCIO's data management layer allows for complete visibility in real time and over chosen periods and locations. Our integration layer lets you integrate SCIO's plug-and-play solutions into your existing systems seamlessly, quickly, and without disrupting workflow. With SCIO, you can bid farewell to inefficient testing processes and waiting times. When measurement is done automatically in the field, you'll immediately have the data you need to make impactful decisions and the operational flexibility to scale as needed, resulting in better yields, higher and more consistent quality, and less food waste. You win, and the world wins. SCIO, instant, accurate, intuitive. Agriculture.
All right. I hope that video helped all of you who maybe are not so familiar with SCIO to get a little bit more familiar with what we do. But at a glance, our company, we're a technology company. We provide solutions for generating quality data, primarily in the worlds of agriculture and food. The grain industry is definitely a big part of our business. It's not the only one. We serve also other parts of the industries like fruits and vegetables, food items like the dairy industry and the meat industry, etc. But the grain business is definitely one of our largest businesses. We work with many leading companies in the worlds of agriculture and food. You can see some of them here. And we have hundreds of customers, but we also serve single farms throughout the world, in the United States, in Latin America, in Europe, and other places. All in all, having thousands of users or subscribers who would use our technologies in the different use cases. Our solution is basically composed of three main parts. We have the hardware part, which are basically instruments that we provide, hardware instruments, portable ones that include our proprietary technology inside. Then they will communicate with a mobile phone application, and eventually we have a cloud system. So our devices include an optical spectrometer that would scan the sample. This is the SCIO CTO. We'll present it in more detail in a minute, and the SCIO Mini, and they both have a sensor that will read the spectrum of a sample. That spectrum will then be delivered to the mobile phone app through Bluetooth. And then once the raw data is received in the mobile phone application, it is sent out to the cloud. That's where it goes through some AI models, machine learning models that we have developed. The models basically analyze the raw data and then send out the result, like, for example, moisture or protein or carbohydrates. And that they send the result back to the mobile phone for the user to observe. So the mobile phone is both a relay as well as the user interface for our customers, for our users. The whole process from scan till you get the result is about 7 seconds. And it's done, practically speaking, in real time. All the information is available to our customers and users on the cloud. So the data, and that's a big part of what we do, is then really available to whoever needs it in the organization, not only the user itself, but everyone else who may need that information in real time or later on may receive it through dashboards, internet portals, APIs, etc. We basically facilitate that throughout our system. Generally speaking, I would say the whole system is designed to be simple to operate, pretty much plug and play. So whoever gets it for the first time, the onboarding is pretty quick, and then you can just get started. You don't have to be a lab professional or some other type of professional in order to really operate it. And that's why it can be used by anyone from, agronomists, people at the elevator, processors, farmers. Everyone who may need this can easily onboard and use our systems. Just to give you an idea, this is a map of all the places where SCIO was used in 2024. So we have a quite broad global reach with our systems throughout the world, mostly located at agricultural areas, but Americas, Europe, Asia, and so on, with millions of scans taken every year. Let me introduce you a little bit to the SCIO CTO. So as I said, we have different portable devices that we provide to the market. The SCIO CTO is the device that's designed for analyzing grain post-harvest. So it's probably the most relevant tool that I want to present today. It has a sensor inside. It's the size of about a large coffee mug or something like that. Let me just show you a quick video so you can get an idea of how it looks from the inside. So you can see inside there's a sensor, a light source, and there's a glass dome, half a sphere inside. And then the grain basically comes in and sits on that sphere. And the sensor can actually get a reading of the sample from the bottom of the cup, seeing a very big portion of the sample at a single scan. Operating the SCIO system is pretty straightforward. There's a mobile phone application. You log in with your credentials. One will have to choose the grain type that they want to scan. That's how the system knows which model to use. Then fill the cup with the grain. Just simply pour the grain inside. We recommend to close the lid, but it's not always necessary. And then just take a scan, wait for a few seconds, and get the result on your app. That's as simple as that. You can always use the app to watch your historical data and what you scanned before. And again, there's other ways digitally to get that information either in real time or later on. Again, as part of our philosophy of making our systems simple to operate, do not require a lot of effort from our users and customers. We develop models, or we call them sometimes calibrations, that are used to analyze different type of grains. So these are pre-made. It's out of the box, basically. There's no development or anything else that needs to be done by the customer. They can just simply start operating these calibrations from day one. We support most of the more important or more widely used grain types like soybeans, wheat, barley, corn, and canola that we're releasing next month. We also support other type of materials. I just wanted to mention some feed-related materials here, like soybean expeller and different types of forages, which potentially may be useful for people in the grain industry. And you can see here the different parameters that we can provide for the different type of grains with the ranges of the different parameters like protein, oil, moisture, etc. And again, that information is something that we can provide at request. But it's important for you to understand that there's no need to develop your own models or calibrations. Just you can receive it and use it as you start working with our devices. It's also important to note that these are all updated from time to time on our cloud system. So our users don't need to worry about making sure that they're using the most updated calibration. It simply happens seamlessly in the cloud, and they just keep using it and getting the most updated version of the models that we have. All right. So there's different ways of how the SCIO CTO is used in the grain supply chain or grain industry. And I'm not going to cover all of them today, but let me just try to give you some ideas of how it's being used. Probably the first use case is just using the SCIO CTO as an analyzer or testing tool in different receivable points. Grain usually are being hauled from the farm to the elevator, to maybe a railway station, to a barge, to a ship, to a processing plant. Can pass multiple locations until it's actually being processed or consumed somehow. All these receival points usually want to measure one or more constituents of the grain, making sure the quality is in place, and that drives decisions like, as I mentioned before, segregation, pricing, marketing decisions, etc. So many receival points will then use our devices for an easy and simple way of analyzing the grain. Device being easy to operate, portable, opens up all kind of flexibilities to our users to use it wherever and whenever they need. Also, the fact that there's no need to have a huge or a very large capital expense from day one makes it easy to deploy in many different locations. So overall, a receival point is definitely a location in the different places of supply chain where SCIO can provide a lot of value, a lot of information. And I guess we'll talk about that later on too. Just to give you one example, in the last couple of years in the US, it's been used in different grain elevators to measure soybeans, specifically to detect or to identify high oleic soybeans where there's a need to make sure that a high oleic soybean shipment or load is not mixed with the commodity soybeans. Having a SCIO cup and the different receival points that can ensure that the actual load is a high oleic soybean and not a commodity soybean makes it simple to operate and maintain this type of need within the supply chain, allowing this type of high value or special type of grain to live within the general supply chain of soybeans. I want to describe a few other use cases that we have in the market, and I think people may find that interesting. One use case is something that we have developed together with a company called Juniper Systems. Juniper Systems provide a solution for measuring test weight and moisture on plot combines, on research combines, for the use of whoever is growing plots of different types of seeds, and they need to harvest tens of thousands or maybe hundreds of thousands of plots every year. And we've worked together with them to integrate the SCIO cup, the core of the SCIO cup into their Harvest Master device that's measuring the weight, basically the test weight. Combining those two together, the plot combine today is capable of measuring every plot, every sample that comes out from a plot, providing the test weight information from the Juniper system device together with the constituent analysis that is provided by the SCIO core inside. So there's no need anymore to save the sample and take it to the lab and have hundreds of thousands of samples waiting in line to be analyzed in the lab. Now the combine can basically provide this analysis in real time and then also make that data available to the other people in the company or in the organization to observe in real time or almost real time and make decisions based out of this, not missing even one plot. So that's an exciting product that we have already for a couple of years now in the market. A different offering that we have in the market is actually with what we call the SCIO Mini. It's not the SCIO Cup. It's a different form factor of our portable units. It has the same sensor inside, but it's being used for different use cases. The one you see here is basically analyzing on-ear corn moisture. That's very important. Obviously, whoever is dealing with corn knows that growing either seed or regular corn, knowing the moisture or reading the trend of the moisture goes down until harvest is very important to time harvest, to time other processes, to understand what's going on in the field. And we've basically providing here a solution that instead of taking the corn out, having to shed it, which is especially difficult in high moisture, we provide a solution where you basically, one will go to the field, remove the husk, and just take a measurement of a few ears and have an understanding of what's going on in the field. together with a digital tool that collects all that information, it's easy to create a very good understanding of what's going on in the field pretty quickly. It's a solution that's been adopted by a lot of seed companies today, and other relevant organizations within the grain industry. Perhaps a good time to mention that we had a SCIO Mini 1 version so far, and we're now releasing a new version of the SCIO Mini, that's SCIO 2, so the SCIO here. It's a really exciting time for us to release this new and improved version of the SCIO 2, but that's probably for a different webinar. Finally, I want to, well, not finally, but I want to mention another use case that's not a grain use case per se. We have calibrations to analyze forage. That's mostly important for dairy farms where they mostly feed forage, and dry matter analysis is super important and critical in the farm, whether it is with fresh corn silage that people need to know the moisture of when harvesting, or whether it is when they feed throughout the year. We support many different types of forages, including even dry shelled corn and high moisture corn, not exactly forage. And we keep adding more and more feed items that are relevant for the dairy industry and generally speaking to the animal feed industry. So SCIO Cup can be multi-purpose in that respect. Now, finally, before I end up that part of the of the webinar, of the slides that I have prepared, I think it's important for us to for SCIO to reiterate the fact that we see a lot of value in providing one solution that can serve the whole industry, providing accurate and reliable information, having one standard throughout the supply chain that's easy to use, that makes the data available in real time, anywhere, anytime. That's our mission. That's what we want to try and do within the supply chain. And we're really looking forward to working with the different parts of the supply chain to make this happen. Also, if there's one thing that I'd be happy you guys remember from that presentation, it's this last slide. All right. Thank you very much for listening to that part. There's my contact details here, or our contact details here. Please, reach out. We work, as you see, throughout the world. We'll be happy to have a conversation with anyone who's interested and provide more information. Now, let's see. So, stop sharing. All right. This was the first part of the webinar. What we want to do now, and what we thought to do, was the following. So I have here Bryce Eger today with me. He was kind enough to join us. As Carrie introduced Bryce initially, Bryce has a very rich experience in the world of grain, working with companies like Corteva, Pioneer, Cargill, and others. Obviously, familiar with this industry, and I thought it would be interesting to have a short discussion about how Bryce and us see the value of something like a solution like SCIO, the quality of getting quality data about grain in the industry. And we'll have a short discussion about this. Hopefully that short discussion can be useful for the audience here. Of course, if you have any questions, please use the chat to add more questions, and we'll try to address the questions as they come. Bryce, again, thank you very much. I think it would be great to start if we can get your angle on the benefit that you may see for for getting that grain quality data information available for the supply chain.
Sure. Well, hello everybody. It's good to be here. And as Damian said, we'll look to the chat and to the Q&A as we get sort of through this. And I see that we've already got a question that came in. But okay, so when I think of the grain industry, there's a few things that are really critical, and you mentioned them as you were speaking, Damian. I think that there's an efficiency and accuracy portion that is very important. I mean, the people on the webinar know all too well the importance of making sure that you have accurate information and data, especially as it comes to binning, storing, blending, and ensuring that you've got consistency of product. At the end of the day, that is ultimately very, very important, and that is an advantage of what SCIO brings together with the SCIO Cup. You said 7 seconds, so being able to actually have a sample viewed and then results back in 7 seconds is tremendous, and openly, not in most cases do you need to be able to make the decisions that quickly, when you're operating a grain elevator or processor. But having that information gives you time to be able to deal with, the whatever may be coming from that sample. So that efficiency and accuracy, I think, is really, really important. The fact that it's real time and it's traceable, so being able to know where that product came from, tie it directly to the sample, and being able to have the traceability, especially as you think about the sheer volume that is going through large facilities. You're thinking about not just tens of thousands of tons, but millions of tons that are going through a lot of these facilities, and being able to trace that back and understand exactly where it may have came from, but then also being able to, most importantly, utilize that information to deal with whatever is coming from the quality of the product. You can then bridge over into sort of the sustainability and resource management, and thinking about it from a farmer's hat. So I'm actually sitting at our family farm today in southwestern Manitoba, and we've got a rain delay, so we're not putting any seed in the ground today. But as you think about it from a farmer's perspective, being able to understand the threshold of where the quality is, understand the protein content. So, honing in on wheat as an example, understanding the protein content, and then understanding where the viability of producing protein is most important, taking that information and then being able to accurately adjust your agronomic practices in the coming years is really, really important, because at the end of the day, there's a threshold for profitability that every farm is also thinking about. So, I mean, those are a few areas that I see that you've kind of touched on and that you've built into the technology that I think really, really do touch every stage of the supply chain in the grains industry.
Great.
Maybe we want to jump over to John's question in the chat. Does that sound good, Damian?
Yeah, absolutely. Yeah, let's do that. Definitely. I mean, first of the question is, are you looking at grain co-products, especially dry distillers grains and others? So the answer is absolutely yes. I mean, I did mention, high moisture corn or dry shelled corn, and DGS and soybean meal and other products are things that we're looking at for sure. It's just that things that are in our roadmap and are under development. Obviously, every different type of material that we need to analyze requires some development work from our side to prepare the models and the calibrations to be available. But we're working closely with with the different industries, including the feed industry, obviously trying to understand the main needs that the industry has, and then provide the solutions for that. For example, I know that there's been some demand lately for this high oleic soybean material within the dairy industry. Apparently, feeding the cows with, or the animals generally speaking, with some high oleic beans may be relevant or interesting. We work with different dairy producers or farmers in the U.S., and this is the type of things that we hear from the market and then try to provide them with a solution. So for sure. And we'll be happy to have more discussions about that offline.
So, Damian, I'm thinking through what you were just talking about. It might be good. You made mention of sort of other metrics and other information and data that the SCIO cup would be able to potentially monitor. So, I mean, if I understand it correctly, I mean, what you've built in today is really I'll say the first tranche and what is most widely, needed, moisture, protein. But NIR technology has the ability to test a multitude of things within the context of grain. So, I mean, what's the process that you would use at SCIO to sort of say, hey, there's value in this for the industry, and to be able to bring on new testing capabilities to the technology?
Yeah, great question. And I want to take it to several places. So I'll start. First of all, since we began working in the world of agriculture and food, we understand very well that we're experts in optics, in technology. We're not experts in agriculture or in food. And so we always listen to the people in the market and try to understand from them what's important. And therefore, we work closely with all the major companies as well as the smaller companies to try and understand the needs that come in the market, and then try to use that as a guide to our roadmap of development. So whatever we hear from the market that's needed, then we go ahead and try to develop it and make it available to the market. I guess that all of the products that we have today in the market are basically started that way. And could be from a question like, do you do dry distillers grain? And then we start poking into it and see if it works. Then whenever we understand that something is really needed and it's useful, and obviously it has a business rationale for us, that basically means that it's needed. Then we'll start trying to develop the solution for that. Developing a solution is basically making sure we have the right model or calibration for that specific need, and overall our solutions support that. That is something that may take between 1 and 2 years until we can make it available to the market. So there is some development time until we can actually make something available in the market. But we throughout that time we will work with different partners in the industry to make sure that the solution works well. So this is the type of things. However, there's two more comments I wanted to say about your question. One is, people sometimes, because of near infrared use, usually they think about it like magic, right? Like it can do anything. And I always keep telling people that it's not magic, and it can definitely not do everything. And then it's also important to remember that in many cases, having the basic or the main ingredients of the material is sometimes the most important thing. So before we run into trying to find all kind of exotic constituents, I think it's important to make use of the main constituents of the material. The second thing I wanted to mention is that sometimes a lot of the development that we do is not only about adding more materials or more constituents, is also making our solutions available in a more easy way and everywhere. So while we do have the portable units that we sell, and these are definitely used, and that's our main business, we are looking to integrate our solutions into other machinery or other places where they can bring value. The integration we did with Juniper to the research combines is a good example of that. But we're looking to expand there as well and make our solutions and our capabilities available to people in the easiest way they can have it. So that's maybe a little bit off of your question, but I guess in the same direction.
But yeah, very valuable as you sort of describe the process by which SCIO looks at new technology or new opportunities, but then also really tries to bring the best value into the marketplace. We're starting to get a few questions in the chat, so why don't I peel off them as they come. So What's the difference in grain moisture content results when comparing these types of equipment versus a primary method like an oven? And what's the average difference in percent moisture content results compared to this method? And that's from Pedro Cadota. So that you got that. You're the nano optics design expert. So how's that? I'm going to put that one to you. Yeah.
Yeah, that's true. Thanks for that. Thank you, Pedro, for that question. It goes like that. First of all, when we develop a calibration or a model, we basically teach our system with AI, with machine learning, how to analyze the raw data and transform it into moisture, for example. So we need to have a reference information, our gold standard or the truth, our truth, basically. So in moisture, for example, we mostly use an oven drying method. Depending on the crop, there will be different types of processes for drying down the crop. But nevertheless, it's going to be the oven method. That's going to be our reference method. So we compare to that as we develop the model. So that's the first thing you should know. And then the accuracy depends very much on the crop itself, and how mature is the model that we have. But usually we are in a very similar accuracy to the gold standard near-infrared spectroscopy laboratory devices that you know. So that would be for most grains. I guess the moisture is around between 0.2 to 0.4 percent. It's called standard deviation or standard error prediction. That's usually the accuracy that we provide. Again, it depends on the grain type, but it's very much comparable to the state-of-the-art near-infrared spectroscopy machines that you will find in almost every grain lab.
Okay, perfect.
Yep.
We've got another one from David Krejci, and he asks, how does the SCIO solution tech align with the official inspection results?
That's a great question too. We are definitely aware to the fact that at the end of the day, there's some official inspection tools or methods that are certified by, obviously the FES, it's different in every country, but in the US as well as Brazil, Argentina, and other places, there's some certification that goes on. We are working to make SCIO certified in different countries, starting, of course, in the US, but then moving towards the rest of the world. This is a somewhat lengthy process. It's not something that takes, 2 weeks. But we are in the process of trying to make SCIO certified. I think that from a performance standpoint, we are very confident that we are able to provide that kind of performance. But this is a process that has to be done properly, and that will take probably a year or so, but we'll get there. So at the moment, we are not we can't provide a certification like a country certification or something like that, but we are definitely in the process of getting there.
Yeah, I think that's so important to your point, right? Making sure that there's consistency of the technology to the standard, right? In each one of the trading areas, and then working very closely to be able to have that, as you said, very easily brought down and calibrated without the user having to do anything, right? Which is really important as well.
For sure. And maybe just to make another point there, it's important to note there's a lot of different types of certifications, even within the United States alone. There will be like a federal or a countrywide certification, but then there's a state certification, etc. So we are working, but it's definitely something that's going to take some time until we are fully certified with everything. We're trying to target the most important certifications in the US and then in other places in the world, and then trickle down to everything else. It's not going to be a quick process.
Yeah, and it is not quick, from a regulatory standpoint and being able to make sure that it's certified appropriately. But the beautiful thing is, as once you receive that, then it really does become relatively efficient to just keep that standard and be able
Oh
to
yeah,
utilize the technology. So that's great.
for sure.
Another question that came in is, could you distinguish the difference, if there is one, between near infrared and infrared technologies?
Um,
That's a technical question.
Yeah, that's a good technical question. So sometimes it depends on one. I mean, near infrared is part of infrared, obviously. So sometimes when people say infrared, they actually mean near infrared. Sometimes they don't. This is just near infrared is a specific part of the spectrum that's widely known and used for this type of analysis of material analysis. It's been used for many, many decades for that purpose. Infrared has other parts of the spectrum as well that we will use for, let's say, for night vision and other types of analysis like heat detection, etc. So, but in our context, in material analysis, it's usually the same.
Okay, perfect. We got a couple more yet to go through that are on the list. Describe the difference of SCIO with other measurement tools. So how does it compare to other tools?
So, as I said, we worked a lot to make sure that we are, at the same level of performance with the other benchtop near infrared devices, that we are well positioned against the wet chemistry, which is at the end of the day the ground truth that we use. I think that comparing with other portable near infrared, where I believe that we are at the top of the performance. We have a very much groundbreaking technology that gives us a big advantage. And so I believe that we're very close to as good as it gets from a near infrared spectroscopy technology. Of course, we're working all the time to make our models more robust, to make them more mature. We keep collecting data and adding to those models all the time. So there's room for improvement, but for sure there's a very good level of performance right now for the solutions.
Perfect. Looks like Agbula asked a question just around the amount of time for results from the SCIO Cup for wheat moisture content. And I think you kind of referenced that it's pretty instantaneous, right?
Yeah, but maybe I'll use that question to also mention one other thing. So for sure, it's instantaneous. We'll get the result within a few seconds. From the time you press scan until you get the results, about 7 seconds. It's all about putting the grain inside, taking a scan, and then getting the results. I would say that there's more advantages than just the speed of getting the information here. Because this is so easy, it helps people to make more measurements and more analysis and get more information. And getting more information in many cases can be the difference between understanding what's going on and not understanding. Because if you take a measurement once every 2 weeks and it's a single measurement, until you actually get a trend that you can understand what's going on, that can take months. On the other hand, if it's so simple that you can take a measurement twice a day, then all of a sudden you'll start seeing trends and effects that otherwise you won't see, or it's going to get a lot of time to understand it. So the ease of use gives a lot of advantage beyond just the quickness of getting the results.
Yeah, that which is very important. I was thinking about this again when you're in proximity to what's actually going on at the farm. It kind of reminds you of what harvest is like around here. And when we're testing, and I see somebody had put a comment, Thomas had put a comment about it's totally portable, not connected by cable or to a larger instrument, and the phone app and handheld device, unlike any other lab-based instrument. It's interesting. I mean, we do our testing two ways on the farm for our cereal grains. Moisture is at a central spot on the farm, so we're bringing samples back to make sure that we're actually calibrating to what we're getting off the equipment. But then protein, we're running it to our local grain elevator, right? And the local grain elevator, when I say local, is 20 miles away. So to from the sort of the center of the farm. So you think about that to try and make sure you're making the proper binning decisions, the proper storage decisions, That's not an efficient way to actually go about that, right?
Exactly. And by the way, it doesn't have to replace your grain elevator, right? You'd go there anyway once every while, but you can still have a lot more information now. Try to figure out what's really coming from every field and have much more information that can drive your decisions. Maybe just touching on Thomas's question as well. So, of course, it's cordless, so it's Bluetooth operated. And it's also battery operated. So there's a battery inside. It's rechargeable with the USB. It's about 2,000 scans per charge. So quite a lot of charging, a lot of usage time before you have to recharge it. Again, we've designed it to be super easy to use. There's a really nice and sleek carrying case with it that is also used to store the device if you're not using it, maybe during winter or off season. So thanks for the question, but it's all designed to be user friendly.
Yeah, and generally, what you've described previously to me is, and maybe just touch a little bit on the durability. I know that it has the storage case for when it's not being used, but inevitably it's going to be, on the back seat of a half-ton pickup, or it's going to be in the grain truck. But overall durability of the device is pretty high from what I've witnessed and seen. So,
Yeah. I guess we're getting close to the end of the time.
yeah, it's gone quick.
Yeah. Perhaps one more question. I just want to end up with saying that one, we're here to serve the industry, and we'll be more than happy to connect with everyone who's interested. Our vision is, making that quality data available. I believe that we will find together with everyone that this can actually make great transformation within the industry. So I really look forward to this type of to getting more and more deeper into the industry.
Looks like we did have just a couple quick questions that came in at the end.
Yeah.
If you want to quickly answer, and then we'll look at wrapping up here shortly.
Yeah. Okay. Great couple of questions to end up with.
Yeah.
First question, is there a monthly subscription for the cloud app? So our business model, generally speaking, includes a yearly subscription fee for the cloud app. And yes, we do have distributors in the United States. We work with UAS out of North Dakota and with Seedboro. But in any case, questions like that, we'll be happy to receive them and work with you to find out, what will make good for the U.S. Market. Please feel free to connect to us. I guess all the information is in the slides and then in the GEAPS website and our website. And please connect with us or with our local distributors, and we'll be happy to serve you.
And from GEAPS, thank you, Damian and Bryce, for joining us. What a great presentation. And yeah, thank you very much.